All right, so we were on this worked example where we were showing that a triangle is right angled, and where we left off when the bell really rudely went is that we are going to show that it's right angled by using Pythagoras. That's the first method we're going to use. Cool. So, Nick, you did it over the weekend. Awesome. What'd you do? Cool. Quote the distance formula for me. Sorry, what was in between them? Plus? Thought you said minus, sorry. That's why I didn't write it up there. Thought I'd better just double check. Alright, so you got that. So, alright, so what have we got to do? How many times have we got to do this? 3. So we're going to do it for what? AB? Okay, let's do that one first. Sorry? Yeah, it doesn't really matter. I personally would go AB, AC, BC. I just sort of work my way across, but that's habit. So AB, what do we got? Square root of. So you're using A as 0.2. So 3 plus 1 squared plus 4 plus 1 squared. All right, you did it with a calculator, that's fine. I'm just going to leave it like that. I'm going to leave it like that for now. So what's the next one? I'm going to do AC. All right, so AC, you're going to do the same thing. So 3 plus 2 squared plus 4 minus 8 squared. 25, 4 minus 8 is minus 4. Ah, we've got 2 lengths the same sides. And now we're going to do BC. Yes, mate? It is 41. Thank you. How come no one else picked up on that? They all think I'm just awesome and never get things wrong. You guys have known me long enough to know that's not the case. Didn't pay attention. It's Monday, leave us alone. Alright, so this last one. We've got BC. So which one are you using first? Doesn't really matter. You used C, did you? Minus 2 plus 1 squared plus 8 plus 1 squared. Catherine, did I get that one right? You'd reckon I could add 16 and 25, but apparently it's difficult. How? You didn't do it correctly. So what are you trying to say? You did it correctly. I just got the wrong answer. All right. So we've now found the lengths of all 3 sides of the triangle. Okay? So if you wanted, you could now draw a bit of a triangle and go, well, I've got square root 41, square root 41, square root 82. Now, actually, no, it's not. It's interesting. Interesting. So now we're going to use Pythag, right? So C squared equals A squared plus B squared. So are we going to call this one that all right? BC squared equals AB squared plus AC squared. Does everyone realise why I chose the ones like I knew which one was hypotenuse? If it's going to be right angle, the hypotenuse has to be the longer side, correct? So I just made it the hypotenuse. Cool? So what I do then is I sub in. So square root of 82 squared equals square root 41 squared plus square root 41 all squared, which is the square and square root cancel each other out. So 82 equals 41 plus 41. Hey, look, my answer comes out exact too. What do I have to do? Sorry? The square and the square root cancel each other out. Square root of 2 squared is 2. Does that make sense? Because the square and the square root are inverse operations. It's like something divided by 3 times 3. When you say in numbered form, you mean decimal? Yeah. Yeah, because what you've got is you've got a situation where you've got rounding errors. But because you've been consistent throughout, all your rounding errors cancel each other out. Yeah. Yeah. I would just... Yeah. Well, it should, because it is. We've just done it with surds, with no decimal places, and it makes life a bit neater. That's one of the reasons we do surds before we do this sort of thing, so that you can use them to your advantage. Okay. Does that make sense, sir? And the good thing is, if you're in a situation where you've got surds and you're using Pythag, you know you're going to be squaring everything. So the surds are going to disappear. Cool? But Pythagoras proves that's true. You all happy with that? Because we have another method. Now, our other method involves this little truth. That. Okay? Either one of these work perfectly. Sorry? Yeah. It depends on what you think of initially. When you think of prove that it is right angled, it depends on what the question says. The actual wording of the question says show that the triangle ABC is right angled. So I would automatically think of Pythagoras. But if it said show that these are perpendicular, I would automatically think of the gradient. Okay, it depends on how the question's worded. But both of those questions would be exactly the same thing. Cool? So what are you actually trying to show in this particular case? You're showing that it's right angled, A, B, C. So what are you trying to do? What do you have to do? To use the gradient, what do you have to do? How many gradients are we going to have? 3, because we've got 3 lines. It's a triangle, right? So we need to calculate all 3 gradients. But how do we use those gradients to prove that they are perpendicular, that it is right angle? Multiply what though? Right. We need to find any 2 of those 3 gradients multiplying together to give us a -1. If we find 2 of them that do that, then we know that those 2 lines are perpendicular. And that's all we need. Okay, because we know all 3 lines are the triangle. That's what we're told. Okay, so let's find M of AB. How do we find the gradient? Happy with that? Now remember, we can have negative numbers here. So what's our 2 points on AB? So give me my y2 minus y1. I can't. Otherwise, I've got to scroll up, and I'm lazy. Sorry? Yeah, but I want the points. Minus 1 minus 4 over minus 1 minus 3. Cool. So they're my y1, y2, y1, x2, x1. G equals minus 5 over minus 4, which is the same as 5 over 4. Now do the gradient for AC. 8 minus 4 minus 2 minus 3. I'd probably stop there, personally. I can see it straight away. Yeah. Yeah, okay. Cool. That works. If you're not sure, then you'd have to do the third one. Like if it didn't work out quite as well as you'd liked. So what would the gradient for BC be? Minus 1 minus 8 over minus 1 plus 2, is it? Okay. But after those first two, AB and AC, you should have been able to stop and look at it and go, well, hang on. 5 over 4 times 4 over minus 5 equals minus 1. Therefore, ABC. Cool. That make a bit of sense? Once we had those two, we were pretty confident. All right. So I'm going to stop this one.